NASA
in its stacked configuration.
Antares NG-19
Again,
Launch.
Antares is a two-stage rocket. It's got the
coverage,
liquid oxygen oxidizer and RP1 kerosene fueled on the first stage.
All right.
Second stage is a solid rocket motor. And of course, Cygnus will be following along. The deployment of those ultraflex solar arrays happens about 2.5 hours after its insertion into orbit. Those will collect the power it needs to fuel its service module for the remainder of its flight to the International Space Station.
Okay, so this is the Northrop Grumman NG-19 supply mission for NASA. NG-19 is launching the... NG-19 is aboard an Antares rocket. This is an Antares 230 Plus, or 230 Plus. Cygnus was that spacecraft with the circular solar panels. It's a spacecraft that's designed to go up and resupply the ISS. It's basically just an empty can. You can put whatever you want in it with the service module on the back, with a little propulsion system, right? Cygnus launches this thing out of the Mid-Atlantic Regional Spaceport, or Mars. So that's Wallops Island, Virginia, off of Pad 0A. Antares is a two-stage-to-orbit rocket, the first stage being kerosene and liquid oxygen. It's a liquid fuel stage powered by two RD-181s in the first stage. And then the second stage, believe it or not, is a vacuum-optimized solid rocket booster called a Castor 30XL. Riding on top of the solid rocket booster, there's a live shot. Riding on top of that solid rocket booster is the Cygnus capsule and its payload attachment fitting. This is kind of a high-profile launch, guys. The reason why it's high-profile is because this is the last time you're ever going to see this rocket in this configuration fly. The Antares 230 Plus is being discontinued due to supply line issues, overseas supply line issues. So, yeah, the Antares rocket will come back, but it will come back with a different first and second stage in the future. There you see a live shot at the top of the first stage right here, and then inside of that inner stage right there, that's where the second stage rides. It rides in there, and then the payload fairing up top that says Cygnus with the flag on it. It's a solid vacuum optimized solid rocket booster pop. Yep, that's the last. This is the last time you're going to see an Antares 230 on Pad 0A at Mid-Atlantic. Interesting thing, you can see other launch providers have taken up shop right there at Wallops, which is pretty cool. There's more orbital class rockets launching from Virginia than most places in the world. There's 2 of them. Antares being one of them. Yeah, it's a good flag, everybody. Antares 330 will debut in summer 2025 with NG-23. Yep.
That are happening. First, we have Christina Halona,
currently
Antares
about
Systems
15 minutes
Engineering
out.
Program Manager at Northrop Grumman. Christina, do we have you?
Hi, Gary. Yes, you do have me. Thank you. I'm excited to be here, and many thanks to everyone joining us today to see a successful Antares launch and Cygnus mission to the International Space Station.
Thanks for joining us, Christina. It's been a bit to get this vehicle in its position that we see now. Can you take us through what it took to get Antares into this vertical position, specifically the rollout?
Sure. This is Northrop Grumman's 19th mission, as you had stated before, and it definitely takes the entire Northrop Grumman team from Chandler, Arizona, and Dulles, Virginia, months and months to get the Antares 230 Plus vehicle ready for launch. It definitely starts with the vehicle being manufactured there at the Horizontal Integration Facility, which we call the HIF, at Wallops Flight Facility. And then we roll out the Antares rocket to the Pad 0A. It's definitely a rain or shine event. Thankfully, this week we rolled out Antares to Pad 0A, and where we have several engineers, about 20-ish, 30-ish people from various disciplines, and they all walk with the vehicle from the HIF to the pad. It takes the entire team are looking while they're walking out with the rocket. They're making sure that Antares stays level the entire way. We have a requirement where we have to stay within a 1 degree side-to-side requirement the entire rollout, and the whole process takes about 2 hours for Antares to make the trip from the HIP to the pad. And that's all due to the slow pace of the vehicle taking the vehicle on the truck, and we go a staggering 2 miles per hour. So as you can tell, it's 2 miles per hour is pretty slow. So, but we want to make sure we get it to the pad safely, and once it's there, we undergo some more testing on the vehicle, and then it's eventually loaded and then prepped for launch.
And it certainly did look like a beautiful day. You got really lucky with the rollout there. Awesome to see some of that footage. You know, this is not the first time you've done this, as you mentioned. It's been a while. You're coming up on 10 years since Cygnus's demo mission to the ISS, and more than 10 years since Antares' maiden flight on April 21st, 2013. When you look back at all that's been accomplished over these 10 years, what sticks out to you? You have 16 successful flights. You've been upgrading the Antares incrementally over these years. What really sticks out to you as you reflect on these past 10 years?
They built an on-ramp.
The one thing that Northrop Grumman's very happy to share is that Antares has carried approximately 130,000 pounds of cargo to the International Space Station, and our Cygnus spacecrafts in total have hauled away about 91,000 pounds of waste. So, like you said, over the years we've expanded the capabilities of Antares and Cygnus to increase our cargo capabilities. We perform late loads. We also offer reboost services and perform various secondary missions as well. So here at Northrop Grumman, we definitely understand the importance that the resupply missions are not only to NASA, but their astronauts and the critical research that we've done aboard the ISS. You know, there's been so much, advances of technology that have come from their research in space, and we're definitely honored to be a part of it and excited for all the missions to come, and this one for today, for sure.
So a couple of things here. The rocket's right there. The transporter erector and launcher, the TEL, is right here. That's that cradle. That's the thing that you saw rolling the thing to the pad. That carries diagnostics for the second stage and the payload, and HVAC systems. You can see that's what those. Oh, there's a shot up the business end. That's what those lines are up the side. Those four huge towers that are around the rocket are lightning rods. You don't want the rocket getting hit by lightning. There's a lot of things inside of that can explode. Now they're naming it after Laurel Clark, who was on STS-107.
Along with countless other STEM, women around the world who are wanting to pursue their engineering degrees. It was Laurel. She was an astronaut. She was a medical doctor, a U.S. Navy captain, a space shuttle mission specialist, and the thing that was very special to me is that she was also a fellow astronaut Group 16 classmate of one of my mentors, who is a retired astronaut, Dr. John Harrington of the Chickasaw Nation, who was the first Native American in space. So she really had a tight bond with her entire class, and just knowing that cousin really stuck out to me. And it's her incredible accomplished career and passion for the research in space that helped me cement my work in the aerospace industry. And, it's been 20 years since Columbia's space shuttle tragedy, and where Laurel and 6 others of the astronauts lost their lives. And, it's just been amazing to witness Dr. Clark's career achievements that took her career to under the sea and to the stars, basically. And, she and the entire Columbia crew of the STS-107 continue to inspire, future generations of explorers. And Northrop Grumman is proud to commemorate our NG-19 Cygnus spacecraft, the SS Laurel Clark, for the NG-19 mission, where she has made a substantial contribution to the United States commercial space program and to human space flight. So we're very honored to have it named after her, and just a very special place in my heart for her and the entire crew of the STS-107.
And I think that special place is shared amongst the teams that are supporting this mission. Christina Helona, thank you so much for joining us for the launch show, and we're continuing down towards the T0 here at 8:31. Thank you for coming on, Christina.
Of course, thank you.
Okay, the other big thing, aside from the 4 lightning towers here, is the gigantic water tower there. That's just spray down the pad with water. Those are the HVAC lines I was talking about, making sure that the payload stays cool and the second stage stays cool as well. It's a solid rocket booster. You don't want it getting too hot.
And as mentioned, as we were talking with Christina, the milestones for counting this mission down to T0 have been moving along.
Okay, Launch Team LC, we're coming up on our poll to proceed with final countdown. This is step 414.
I have
GSO.
Erudite. I've seen one from very
GSO,
close,
go.
from where this camera is
RSO.
actually.
RSOs go.
Range safety
TD.
officers, green.
TDs go. Prop lead. Prop leads go.
Propulsion.
Stage 1.
Stage 1.
Stage 1 is go.
Okay.
MES 1.
MES 1 is go.
GCE.
GCEs go.
ACE.
Aces go.
Mars.
Mars is go.
CMD.
CMD go.
LD.
LD is go.
Launch
NG.
director reports go.
Northrop Grumman is proud to honor accomplished NASA astronaut, medical doctor, U.S. Navy captain, and Space Shuttle mission specialist Dr. Laurel Clark. Laurel was a passionate contributor to the space program, improving our understanding of spaceflight effects on the human body. Her crew's successful completion of 80 experiments on the STS-107 mission advanced the bioscience knowledge of plant growth in space. A proud and dedicated wife and mother, Laurel spent most of her free time during the mission conversing with her family. But when she did get time to look out, she described it as glorious. It is therefore an honor to return her legacy to space to once again enjoy the view as the SS Laurel Clark and Northrop Grumman
I'm
are
going to run an ad,
go for
guys, so
launch.
nobody gets an ad during the launch.
Copy that. We are good to proceed with final countdown. Check step 414. Godspeed, Patrick James.
And with that, we pass the 10-minute go, no-go poll for CRS-19 to lift off on time this evening.
Engine evac.
Hey, all stations,
engine evacuation started.
pitch and back as. Check your headsets and mics. You might have a hot mic.
Oh no.
And engine evacuation started.
Engine evac is purging out atmosphere out of the engines and basically filling some of the components with inert gas. So when you go to flow propellants in to the motors, they're not combining with atmosphere or anything. We are at 10 minutes.
For engine.
I'm just fast forwarding to get caught up here. There we go. I'm going to move over here because they put the countdown time.
8:31 and 14 seconds p.m.
This is
Eastern
Wallops
Time.
Island, Virginia, everybody.
LC, MES-1, vacuum verified in the fuel circuits.
Okay, MES-1, I copy that. We'll check 416 complete.
You should be able to see it in fairly high vis, yeah. It's going... I think this is launching on a southeast trajectory out of here. Yeah, it is a southeast trajectory. It's looking up the business end of the two RD-181s. Actually, technically they're two RD-191s, but when you take two RD-191s and put them on Antares, it's technically an RD-181, which is some weird naming convention.
Live shots of the liquid rocket engines that will mix RP-1 kerosene and liquid oxygen.
To go to enable ACS VDMs.
Those two motors right there.
LC-1 ACS VDMs internal power on.
Attitude control system.
LC-1 ACS VDMs enabled. Voltage nominal. ODM commands are clear.
Copy, Elec 1. We'll check step 417 and 418.
Those engines are oxygen-rich staged combustion cycle motors. Basically, it's a type of motor that when you deliver fuel, it atomizes the oxidizer first and turns the oxidizer into a gas and then combines it with the liquid fuel RP1. The end result is an engine that runs super freaking lean, so you
A
end
little
up...
bit about what to expect for Antares Ascent. It's a two-stage rocket, so they...
I already said that. You end up having a extremely efficient burn that's extremely powerful, but really, really hot. Those motors get really, 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 really warm.
Separation about 3 minutes 24 seconds, and fairing separation at 3 minutes
34 months,
54
thank you. Hey, Aaron.
seconds. There's an interstage separation, and then the stage 2 ignition after 4 minutes. And this stage 2 is a solid rocket motor that burns for 2 minutes and 44 seconds. After another coast period,
It's near
the
Chincoteague
spacecraft will
Island.
separate from the second stage shortly
Wallops
after
is out in
9
the middle
minutes
of nowhere, dude.
to insert
I've been there. It's nice. It's beautiful.
Cygnus
Very
into
quiet.
orbit.
Except for the rocket. I did run ads, Shy.
Admin copy.
inside of 7 minutes now. NG-19 on the pad. Everything is looking go at this point.
LC top baby up 421. VTSL activation verified.
Copy that. Check 421. Ops 2 initialized ground ordnance power supplies.
Ground ordnance power supplies initialized. LC Elect 1 ground ordnance power supplies are nominal.
Copy that. Elect
The
1.
ground
check
ordnance is the
422 and
separation
423.
mechanism. Antares has 4 explosive bolts down at the bottom of the rocket. The explosive bolt blows up, and that allows the rocket to leave from the pad. It's bolted
T-minus
to it.
6 minutes and counting.
But
sun
the
is setting
bolt
on
has
the
a
East
shotgun
Coast there.
shell basically
Antares
inside of it. They
sensing
just
is
switched on the
illuminated
power
by
systems
the floodlights
for
on the
their
launch pad.
separation
That's pad
mechanism.
0A at the Mid-Atlantic Regional Spaceport.
Initiated. Time 002503.
Copy that. Check 425 complete.
Nice, Andrew. That's good, man. Good for you.
And
LCCMD, step 413. Cygnus is launch mode and nominal.
copy that. CMD.
Friend.
Control, can I get a call on 424?
You can, LC. I can confirm activate ECS transfer to GN2.
Copy that. Check 424 complete.
5 minutes, 15 seconds. Cygnus, inside the fairing that you see at the top of the rocket there, behind the American flag, is configured for launch.
Ops 2 LC, step 426. You're good. Initiate engine priming.
Engine priming started.
Okay.
Copy that. Ops 1, transfer avionics to internal power.
LC Ops 1, all internal power on, all external power off.
Okay, so they've switched the rocket onto its own battery power. It's
LC Elect 1,
disconnected from the
internal power
grid.
nominal.
Ops 1, open FTS umbi-loop.
FPS umbi loop open and green.
Flight termination system umbilical loop. That's basically the abort system. Look east, southeast, Peterson.
FTLU and FTS receiver indications are nominal.
Ops 1, you go to send all arm command.
LC Ops 1,
Pretty good,
all armed
yeah.
and sent.
Cockadilla.
LC Elect 1, safe and armed, and ODMs are all armed.
NASA TD, report range status.
That's the
Range is green.
range is reporting green. There's no planes in the range. That's the explosive bolt. That's just a separator mechanism right there. But the explosive bolt is right there. There's 1, 2,
LC,
3,
FTS
and
1,
then 4.
priming verified. Copy that. MES 1, check step
Voodoo,
434.
what's up, dude? Nero, how you doing?
Inside 4 minutes from launch, the team's reporting that the range is green. Antares makes a southeastern track down the eastern seaboard and across the Atlantic. If you're on the East Coast, there are maps that allow for certain visibility of Antares, and in this night sky, you may get a good view, though we are hearing it is a bit hazy on the upper altitudes, so there might be some cloud coverage that prevent sightings, but for those that are close to the Mid-Atlantic Regional Spaceport over at Wallops Island, there may be some sightings to the first leg of ascent. 3 minutes, 15 seconds and counting.
LC Elect 1, FC command is in flight.
Copy that. Check 437.
Yeah, Ilya, this is the last for this version. It's the last one that's going to use Russian motors.
Elect 1.
Inside of
LC,
3 minutes.
Auto sequence startup.
Copy Elect 1. Be advised you're coming in faint.
ODM bus voltages and currents are nominal.
Copy
Okay.
that. Check 438, 439, and GNC1, verify ready for nav mode.
Electrical says they're getting good power to all systems.
LC GMC1, ready for now.
Copy that. Ops 2, switch to nav.
LC Ops 2 switched to nav.
Check 441.
LC GMC1, nav mode verified.
Copy that. We'll check 442. And we're at T-minus 2 minutes and counting.
2 minutes. Yeah, QED, it's going to be hard for us to see. It's going to be low on the horizon, due south. Like, almost straight due south. Kira, how are you? This is Wallops.
T-minus 1 minute, 30 seconds.
It's out of Mid-Atlantic Regional, Delicious. This is in Virginia. $60 seconds.
T-minus 1 minute.
That's right, Pete. Okay, here we go.
T-minus 30 seconds.
30 seconds from the mission director.
Discovery, go at throttle up.
Laser drifter.
T-minus 10.
10. Sound suppression system
5,
should be turning on.
4, 3, 2, 1.
Ignition. Yeah, baby! Separation confirmed. NG-19 is in the air. That was sweet!
Antares taking Northrop Grumman's commercial resupply mission 19 into orbit to the International Space Station.
Fly, baby, fly.
Power remains nominal. Last is nominal.
Power from mission control.
Flight controllers reporting a nominal ascent for Antares.
Nominal.
Attitude nominal.
Pressurization is nominal. Engines remain at 100% thrust and steady.
Okay. Guidance, navigation, and control
Visual
reports
TVC is
nominal
nominal.
trajectory.
Attitude nominal.
Vehicle attitude remains nominal. Pressure power is nominal.
Vehicle passing through max Q.
Vehicle now passing through max Q.
Max Q is the maximum dynamic pressure experienced on Antares.
Pressure. Sorry, Gary.
Core pressurization valves are nominal. Engines remain nominal and steady. LCA, your go.
Godspeed, Antares.
Thank you, LCA.
Southeast. Shot.
Half through the burn. 100 seconds to MECO. Passing to 30,000 feet.
Attitude nominal.
Attitude remains nominal. Engine remains nominal, steady at 100%.
Discovery, go at throttle up.
Passing through 5,000 feet per second.
Shot C.
Core pressurization remains nominal. Electrical power is nominal.
Okay, everything's nice and peachy here.
TVC remains nominal. Engines remain nominal.
Everything looks good.
Electrical power is nominal.
Sometimes 8-bit. Depends on the launch.
Core position is nominal. We're approximately 40 seconds from MECO. Slow throttle down has begun.
So they're throttling back to limit the G-forces on the booster.
TBC preset down slow is started. Attitude remains nominal.
So when the booster's
3
cut
minutes
off,
into the flight of Antares, we got about 15 seconds until
unload,
main engine cutoff.
Rapid throttle down, steady 55% thrust.
should be about 10 to 15 seconds to main engine cutoff.
And we have main engine cutoff.
A little bit quicker than that.
Alice is taking care of business.
Okay, good separation. Attitude control system is online. There, you can see it
stage
pulsing.
separation.
This is real telemetry,
Switching
guys.
to animation with confirmed stage separation as we lose Antares
coast
into
for
the
a second,
clouds on
guys.
this hazy evening.
Enabled.
ACS is enabled.
Stage 2 ignition time expected at mission time 2:40.
The arrow's taking it a little bit. You see that? See the rates? It's got a positive pitch rate.
Ignition expected. Stage 2 ignition expected in approximately 10 seconds.
Fairing separation confirmed.
Fairing
Attitude
separated.
control systems keeping it nice. Interstage jettison. Stand by for upper stage ignition.
Antares currently in a coast phase.
Stage 2 ignition. And
Got good
TBC
ignition.
battery is nominal.
Second
indicate
stage
good
solid
ignition.
rocket motor has ignited.
Power remains nominal.
The stage will burn for 2 minutes and 44 seconds.
Looking at
The Caster 30XL will burn for approximately
about
2.5.
1.5 G on the acceleration rate, maintaining 15 meters a second per second.
Power remains nominal. Stage 2 TBC is nominal.
Flight
Orbital
controllers
velocity is
reporting
4,500
good
meters a
performance
second.
on the second stage.
Altitude is 140 kilometers. You can see up
Power
here,
remains nominal.
as the booster drains fuel, the thrust stays at a constant output. So as it drains fuel, it actually gets lighter in mass,
TBC remains nominal.
and your acceleration goes up. We're now approaching 2 Gs of acceleration here.
And power.
Discovery, go at throttle up.
No, Nick, everything's good. Yes, it has hired.
We are approximately 100 seconds.
Past
Stage
2G
burnout.
acceleration, that SRB, the Caster 30XL second stage, is really cooking
Attitude
now.
still nominal.
Attitude remains nominal. TBC is performing
Orbital
nominal.
velocity is 5.31. The magic number that we're looking for right here is about 7,600, or 7.60. Altitude is 163 kilometers and increasing.
Power remains nominal.
We are approaching 3G acceleration on Cygnus. 3 Gs of acceleration. Apogee is currently set at 186. Perigee is minus 3,500. Inclination
Stage 2
50
TBC remains
degrees.
nominal.
Inclination is the tilt of the orbit, meaning this thing launched southeast out, basically making a 50-degree angle relative to Earth's equator. Perigee is still negative, indicating a suborbital velocity. When this number hits around 7,600, this number should go positive.
50 seconds.
I'd
Stage
get out and look south right now. Okay, we're approaching 4G acceleration on that second
TBC,
stage. 34
power
meters a
remain
second
nominal.
per second. Velocity is above 7 kilometers a second. Altitude 181, apogee 188. Okay, right now Antares is doing a radial in-burn, slight radial in-burn to
TBC
push
power
perigee
remain
up to
nominal.
positive here. Okay, we
Again,
are
see tail
circular.
off and motor
Stand by for second stage engine cutoff.
Have stage 2 burnout.
Tail off on the SRB is good. Deceleration rates went
6
down to
minutes,
0.
55 seconds into the flight.
We got a
Second
294 by
stage
177
solid rocket motor
insertion at
has burned out.
51.6, which is the ISS's
ACS
inclination.
enabled.
ACS enabled.
7.54, slightly
Now entering
below
about approximately
orbital,
a 2-minute
because
coast
they're going to
phase.
dump the
Antares is in
SRB.
Orbit and will coast for roughly 100 seconds prior to payload separation.
This is a live stream of telemetry. Nice, Belt. No, it's not northeast. This is live telemetry. This is why I like Antares launches, guys. They show you the rates. I can tell exactly what the vehicle is doing by those three. I don't even need this. So, the reason why it stopped the SRB slightly short of orbital, like 300 by 177 is technically an orbit, but it's not stable. The reason why is because they're going to get rid of the Castor 30.
45 seconds into the flight of Antares.
They're going to get rid of that Castor 30 XL.
After spacecraft separation, it will take approximately 2 hours, 30 minutes until the solar arrays are unfurled to start collecting power for the Cygnus vehicle. Shortly after spacecraft separation, we'll have a representative from the International Space Station program online to provide
what the hell, NASA?
Flight of
Antares. Are you kidding me?
Some comments on Cygnus's journey to the International Space Station. We'll plan to wrap our coverage shortly after orbital insertion, but please stay tuned for updates online.
They spent all the money on the telemetry, I guess. Northrop Grumman pied those. Okay. All right.
Spacecraft separation is coming up on 30 seconds.
It's gonna separate in a second.
Continues to coast prior to payload separation.
That sucks, Gratian. Blame IT. Yeah. Okay, we got a good separation of the spacecraft.
Payload separation.
Slight rate increase there from the decoupler. That's the decoupler acceleration right there. See that tick in the X-body acceleration? This is the X-axis acceleration.
The flight control teams confirm the visuals you're seeing here on the animation.
And it looks like there was
Cygnus has separated from.
Looks like there was a slight rate imparted on the vehicle from when the second stage fired its attitude control system. See that little bump right there? Pretty cool. The RCS from that thing, as it separated, pushed the stage a little bit. We saw a slight increase in acceleration. Hello?
We've confirmed that we've had Cygnus separation. Congratulations to the Cygnus team, and that sound you heard a little earlier was
funky there for a
mic drop.
Hello?
You're getting a live view of the Wallops Range Control Center. This is the team that was overseeing the launch of Antares from Pad 0A over at the Mid-Atlantic Regional Spaceport. You can actually see in the back row there, International Space Station Program Manager Joel Montalbano, the pink shirt with the red tie, congratulating the teams and overseeing a successful launch of 8,200 pounds of cargo to the International Space Station.
He runs the ISS.
Meanwhile, in Dulles, Virginia, the journey has just started for the flight control team over in the Mission Operations Center there.
It was probably a signal handover, Josh, if I had to guess. That's what makes the telemetry wonk out like that. Nice, Neuro.
Of course, the operations today were executed by the team you see on the screen here, International Space Station Flight Control Room. We've been monitoring every step of the countdown and Antares flight and delivery of Cygnus into orbit. Successful delivery from Wallops. Thanks to the Wallops Range Control Center team there, all shaking hands and congratulating each other. And of course, Northrop Grumman Mission Operations Center. They'll be overseeing Cygnus's flight, as well as us here in the International Space Station Flight Control Room to ensure a safe journey over the next couple.
So this is Mission Control Houston. This is Northrop Grumman's operations, and that's the Wallops Range Control Center. I know I'm not just reading the names. I can tell you what everything does. This is the Mission Control Center for Houston, for NASA missions, for the ISS. This is Houston, we have a problem. That's that one. These guys here are the ones that are operating the mission. So they're in charge of the Cygnus spacecraft, okay? So that's where we heard the people talking, rock report, range stat, blah, blah. Like, that's these guys over here. This one right here is the Range Control Center. Range Control Center is for the uninitiated rocket scientists out there. Range Control Center is the tower. It's like air traffic control, but for rockets. They're controlling the range of area where the rocket goes up and make sure that nobody is there. They make sure that no people are near the pad, no boats are in the water, and no planes are flying inside of the temporary flight restriction. That's their job.
Yeah, that's a great question. I think three come to my mind pretty quick. The first would be this is the final iteration of the Sapphire series of spacecraft fire protection experiments, and so that's flying on this flight. That's been a really interesting set of experiments, and we've learned a tremendous amount, to be honest with you. The second, I think, we're flying some neural cells that will be cultured in 3D cell models for gene therapy testing. The experiment is called Neuronics. Gene therapy shows promise, but the 3D models needed to test these therapies do not form in Earth's gravity, so creating these 3D cell cultures in microgravity could provide a critical platform for drug discovery and gene therapy testing. So really, really cool stuff. The last would be we're actually flying a new potable water dispenser. We're actually calling it our Exploration Portable Water Dispenser. It provides hot water and improves sanitation for the crew's use.
Hey,
this will double the number of water dispensers that we have on board and certainly speed up meal preparation. Because I think, as you know, and most of our listeners know, because rehydration is required for so many of the crew's meals, having one dispenser, I'm sure takes a while for meal prep. So I'm sure the crew will be very excited about that.
Immolated,
yeah, I'm sure if they had any direction into what...
That's more of the water cooler. You know, the thing where you open up the thing, you put your water in it. That's what that is. It's a sink. I mean, if we really want to reduce it to its base element, that's the kitchen sink with a faucet. Just in space, it looks a little different.
We're 10 years into it. We're talking about the Commercial Resupply Services 19
Not to be confused
mission.
with
so
the
if you reflect on the past decade, what can you say about the impact of commercial cargo operations for International Space Station and continuing to support the operations?
I thought you said line is fully expected to have RGB.
Yeah, in a word, I'd say
that adds
essential.
At least 3 gigahertz
critically
processing
essential.
power.
I don't think that's
obviously
almost redundant, but you know, with the retirement of the space shuttle, we lost our capability to resupply the ISS. And cargo resupply from U.S. companies is critical to our mission. I can't emphasize
showing the replays
that enough.
right now.
It ensures our national capability to deliver critical hardware, science research, significantly increases the ability of NASA to conduct new investigations. Other U.S. government agencies, private industry, and academic and research institutions can also conduct microgravity research through our partnership with the International Space Station National Laboratory. But again, in a word, it's absolutely essential.
It's essential for the operations and continuing operations. I think for this particular mission, there's also a sentimental value to it. And as you know, Cygnus spacecraft get named after significant contributors to human spaceflight. And this one is named after Laurel Clark, who tragically lost her life aboard Space Shuttle Columbia in 2003. And it can be a reminder of the risks of human spaceflight and the work that has been done over the past 20 years to continuously improve mission safety and assurance. So after today's successful launch and you reflect on the risks of human spaceflight, what can you say about maintaining a level of vigilance and NASA's role in working with private companies to ensure lessons in safety are shared and implemented?
Yeah, that's a really good question. And, you know, my hat's off to Laurel and her entire crew. And you know, we'll never forget those guys. You know, focusing on the fact that safety is a top priority at NASA and the lessons learned are deeply embedded in our culture. We share our lessons learned with the younger generations as they enter the workforce, and we work collaboratively with our commercial partners to ensure the lessons are passed on and openly shared and implemented to ensure our future success in human spaceflight. The other thing I'd add is, following the Columbia accident, NASA formalized an additional level of diligence by defining institutional technical authorities for safety, engineering, and crew health. These senior engineers and doctors work to ensure all concerns are heard and work to resolution not only for NASA hardware, but in an ever-expanded role to ensure our lessons learned are shared with both our commercial and international partners. You know, what we do is not easy, and yeah, you just got to keep your nose down.
Powerful words, Jeff, and I think it's a testament to the success of this launch. It makes it look easy that we just lift off the pad and go into orbit, but certainly a lot of work was put into it. Jeff Aaron, thank you so much for joining us for today's coverage and providing these remarks. Appreciate you coming on.
Yeah, thanks so much, Gary. Appreciate it.
That was Jeff Aaron, Manager of Systems Engineering and Integration Office at the International Space Station Program. With that, we will begin concluding our coverage for today's launch. Again, Cygnus is in orbit after a successful orbital insertion by the Antares launch vehicle and it will make its journey to the International Space Station, rendezvousing Friday for a capture and berthing. You can tune into our coverage then. On Friday morning, we'll begin our coverage at 4:30 a.m. Eastern Time. We're expecting the capture by the robotic arm, controlled by Woody Hoberg, the prime robotic arm operator, and backed up by Frank Rubio at 5:55 a.m. Eastern Time, 4:55 a.m. Central Time on Friday, August 4th. Now, since this is a berthing operation, we'll break our coverage and begin the installation coverage at 7:30 a.m. Eastern Time, 6:30 a.m. Central, where Cygnus will be maneuvered by the station's robotic arm and berthed to the Unity port of the International Space Station. This is the center node that is part of the International Space Station and the common home for Cygnus vehicles that arrive aboard the orbiting complex. Now again, we're about to wrap up our television coverage, but stay tuned online for updates on the unfurling of the ultraflex solar arrays on the Cygnus that will provide power for its journey and arrival at the International Space Station on Friday morning. Now, for now, that will wrap up our coverage here in Mission Control Houston. Thank you for joining us.
Attitude control system, secret.
It's a new era of pioneers, star sailors, thinkers, and adventurers.
3, 2, 1, 0. All engine running.
Let's go.
What the f... Bill said that's enough excitement. We can't have more
Discovery,
of
go and
that
throttle up.
you've been putting. All right. Okay, well that was Antares 230. That was the last Antares 230 plus rocket. The last one to use Russian engines, last one to use a Ukrainian core. It's kind of crazy because Antares at this point has been flying for about a decade, but with that kind of configuration, they've been up. Northrop Grumman, well, Orbital Science and Orbital ATK, then Northrop Grumman, they have been upgrading it over time, and it's actually, yeah, that's pretty good. So, the next one actually is going to be using a Firefly engine from another company called Firefly Aerospace. That's the Antares 330. We should be seeing that in a couple of years. In the meantime, Cygnus, that Cygnus capsule for ISS resupply will launch on Falcon 9. Of course. Oh boy. What a Chad rocket. No, you know what? No, it's not a Chad tier rocket. It's a Ken tier rocket. It's Knuff. SpaceX calls the integration hangar the Mojo Dojo integration hangar. It's true. So we're single rocket limited in resupply. Yep. Casa House. Yep. Mojo Dojo Casa House. Was the reason they used a Ukrainian body and a Russian engine was to keep the Russian engineers employed? Arms exports. That's correct. Turns out the Russians actually make a pretty damn good first stage engine, but not anymore. Sure, that won't come back to bite us at any point. Whatever. Well, what do you know? It looks like Dazzle Camo 95. Check out the staging footage that NSF got. Let me see.
Yeah.
And there's ignition of the upper stage.
Oh!
All right, look at this.
And you can see
wow.
the upper stage behind it.
Wow!
Fairings.
No kidding. That is the exhaust of the second stage pushing it forward in the fairings. No kidding. We need to send cameras up the coast more often, Sawyer.
You're not kidding. Holy smokes. This is great. And again, it's
really
interesting because this is the
See some
solid
stars
rocket
going
motor,
by.
so it's
That's
a
the
little
first
different
stage
from
right
those
there.
liquid engines. The view on that, it looks almost like a comet right now. It's amazing.
Yeah, it does look like a comet. And this is the rays of the sun illuminating the side of the solid rocket plume as seen from the coast. If you're up the eastern seaboard right now, make sure you're looking out the window over the ocean and see
Could be
if
the
you
fairing
can
pipe,
see this
those.
yourself. That is amazing.
Or the interstage. Could be any one of them.
Unbelievable.
So that was from our buddies over at NASA Spaceflight. Go over there if you want more views like that. They're a bunch of good dudes. I do work for them from time to time. Oh yeah, I buy brake pads from them. I thought we were watching cartoons. Anyway. Huh? What? Oh, yeah, coverage is over. Yep. Boat, break out another 1,000.
Discovery,
Right? Anyway, guys. Hey, Lev4713 sub. Thank you very much. Thanks for the coverage. Yeah, no problem. No problem. So, fellas, I'm going to call it here for the night. I'll see you guys early tomorrow. Or, not early. I'll see you guys probably around noontime tomorrow. Tomorrow, we're going to get back into the Star Raker build. I know that if I start playing a game again right now that I'm going to play it for another 5 hours. And I'm trying to unscrew up my sleep schedule right now. So let's go see who's out and about.
Discovery, go at throttle up.
Dangaroni, 35-month resub. Remember, tomorrow is a long one because of SpaceX. Yeah. What's today? Oh yeah, yeah. Tomorrow's stream is gonna be like a 14-hour stream. 14-hour stream, Kerbal, some other things maybe. Should be pretty good, pretty good. So what do you guys want to do? You want to watch more Satisfactory? Edtal's playing Satisfactory. Racing Pro's playing Satisfactory. That's pretty cool. Scrotinator, 23-month resub. Appreciate it. And the next day for Electron 2. Wait. Oh. All right. All right. The latter half of this week, we're going to party hard, man. It's going to be sweet. All right. Let's see. You know what? Let's pop over to Edtal. I don't mean to just keep rating him, but yeah, I think that's good. That's fine. There goes your sleep schedule. I'll be fine. Let me get some sleep tonight. Let's go see what Italix is up to. And we'll go from there. So, go give him a raid. Post some of my panel emotes in the chat. He's playing Satisfactory. He's working on his new factory. And I will see you guys all tomorrow. Yeah, the next couple of days are going to be some pretty long streams. I will say that on Thursday, guys, I'm not going to be here until about 4. While I have your attention, I have some stuff that I have to do. So I'm not going to be here. I'll be here probably late on Thursday. So Thursday stream will be kind of long, but yeah. So thank you very much for watching, everybody. Go see what Edtal's up to, and I'll talk to you guys all tomorrow at noon. Stuff and things. Yep, yeah. Stuff and things. Have a good night, everybody. Thanks for watching, and I'll see you later.